This conference will now be recorded.
So very good morning, students. As we thought, today we'll be discussing current voltage relationship in case of series of inductor and resistor circuit when an AC signal is sent through series LR circuit, and when an AC signal is sent through CR circuit, series C and R circuit. So let us see here in this circuit diagram. So I have resistor R is the resistance here, and an inductor coil having inductance L, which are connected in series. And you can see this is AC source, which is sending a signal of V is equal to V0 sin omega t. So this is sinusoidal signal, and frequency of that signal is omega. Okay. So we have already seen in case of this pure resistive circuit, what we have seen, the voltage drop VR is equal to IR. Okay, so this obeys Ohm's law, right? Ohm's law. Okay. In case of inductor circuit, like pure inductor AC circuit, we have seen the whole potential is dropped across the inductor coil, and that time we have seen that this will be L di dt. This is the voltage drop across the inductor coil. Okay, and see, this circuit can be analyzed analytically as well as geometrically using the method of rotating vector or phasor diagram. So most convenient and easier method to analyze AC circuit is to use the phasor diagram method. So see, if you ask me to do this in terms of like analytical way, that can be done, but it is not that handy to solve or analyze the circuit. It takes longer time. Okay, but easier way to use the phasor diagram or rotating vector method to analyze the circuit. Okay, so we'll use the rotating vector method, and in the rotating vector method or phasor diagram method, what we do, we draw the phasor of current and voltage. So in the pure resistive circuit, we have seen that the current and voltage, they don't have any phase difference. So current will be, the magnitude of the current will be V0 by R, isn't it? So V0 by R, so V, or if I write RMS or instantaneous value itself, if we write instantaneous value of the current, then also this is the thing, instantaneous means RMS only. Okay, so in this case, see V0 sin omega t. So there is no phase difference. Okay, both, see V is equal to V0 sin omega t, and this is V0 by R sin omega t, or we can write I0 sin omega t. That we have seen already in case of pure inductor. Okay, pure resistive circuit, and pure inductor circuit also we have seen I is equal to I0 sine omega t minus pi by 2. This we have already seen. So in case of inductor coil, the current is lagging behind the supply voltage or the signal we have sent, that is V0 sine omega t. Okay, so you look this V0 sine omega t and this is I0 sine omega t minus pi by 2. So current through inductor coil lags behind the supply voltage by pi by 2 radians phase, okay, or 90-degree phase angle. So in case of resistor, purely resistive circuit, we have seen this is V instantaneous voltage and this is, or VR also the same, and this is actually I current. Both are actually, current and voltage both are in the same direction, drawn in the same direction in the phasor diagram. Okay, now I have, see, in case of inductor coil, what was the phasor diagram? This was current I is equal to I0 sine omega t minus pi by 2. Okay, sine is here, the sine I0 sine omega t minus pi by 2. Okay, and the voltage was drawn here, right? And the angle between them is 90-degree. Okay, 90-degree or pi by 2 radian is the phase difference between this. Okay, VL. So VL and this IL means current through the inductor coil. They have actual phase difference by how much? 90-degree. It is I think this is not VL, this is, we should write, this is V is equal to V0 sine omega t. Okay, V0 sine omega t, that means the supply voltage. Okay, supply voltage. So phase difference between supply voltage and the current is pi by 2. So this is how we have drawn, right? So now what will be the phasor diagram for this combination of L and R? We have already learned separately for a purely inductive circuit and for a purely resistive circuit. But then when we send the same signal V is equal to V0 sine omega t to a series combination of R and L, what will be the phasor diagram? So look here, this is the phasor diagram. Okay, so see, this is the current through the circuit. I say the, let us say the current through the circuit is I. Okay, current through the circuit is I. And see here, the total voltage, supply voltage is actually dropped across the resistor, this one, and across the inductor. So let us say the voltage drop across the resistor is VR and across the inductor coil is VL. Now if this is my y-axis, this is x-axis. See, we'll be drawing the phasor diagram. See, this angle is omega t. Okay, this is omega t. This is actually supply voltage. Okay, this is the supply voltage V. All right, so this angle omega t, and see the angle between these two I and L. See, this total angle is omega t plus pi by, sorry, yes, omega t plus pi by 2. Okay, so this is all the way omega t plus pi by 2. Now the angle between these two is actually pi by 2. So angle between current and voltage, what it is? The angle between current and voltage, this supply voltage, okay, not VL. This supply voltage and current. Look this. Current between the current between the, sorry, phase angle between the current and supply voltage is this is omega t. This is actually this is total angle. If I say this is actually phi, this is phi. The angle between these two are phi. So this is actually this is phi. So that phi we have to actually find out. Okay. I hope it is clear to you what is my aim here. We need to find out the current voltage relationship. Current voltage relationship. So in this, what we are going to do, we are going to find out what is the magnitude of the current, IRMS, and what is VL, VR, what is the effective resistance in this circuit. Okay, so these are the things we are just going to do. And main thing is that what is the angle between the supply voltage V and IRMS, or I, simply I. The angle between, phase angle between phase between V and I. V and I. Okay, so this is the agenda here. So look, if you remember, I had already discussed now also. So the current is actually in case of purely resistive circuit or resistor, the current and voltage both are actually in the same direction. That means supply voltage and the current, I'm sorry, this is little, okay, so the voltage drop across the resistor and the current, in that way also we can say the current in the circuit and the voltage drop across the, or voltage phasor of the resistor, okay, they are in the same direction. Okay, but in case of inductor coil, voltage is ahead of the current by pi by 2 radians or 90-degree angle. So actually VL is ahead. VL is ahead. I think we can say this VL and V. Okay, we'll just discuss that later. Let us just do this. See, the voltage, total voltage is actually the sum of the voltage drop across the resistor since we are adopting the rotating vector method, so I have used this vector signs. Okay, now we have to, this one is actually the supply voltage. Supply voltage. Okay, now if I go with the amplitude part, then we can write V0R plus V0L. These are actually amplitude part. Amplitude, when we are writing amplitude, amplitude, this we can write actually V0 square is equal to plus V0L square. Okay, this we can write actually. Okay, amplitude, let me just erase this part. Amplitude square, consider the amplitude. Okay, considering amplitude, considering the amplitudes. So what is this V0R and V0L? These are nothing but the magnitude of VR and VL respectively. So look, V0L or V0R is actually I0R. Okay, and V0L is actually I0 into XL. But what is this XL? XL is the inductive reactance. We have already learned that XL is omega into L, which is actually having the dimension of resistance offered by the inductor coil. It actually opposes the flow of current through itself. Okay, now what we will do, we'll take up this equation and then go ahead. Sorry, come here. Okay, so we have got V0 square is equal to I0 square R square plus I0 square XL square. Now take this I0 square common, R square plus XL square. Now I need to find out what is the magnitude of the current. Magnitude of the current is C V0 square. Let us write this square itself. V0 square divided by R square plus XL square. Now V0 is equal to V0, sorry, I0 is equal to V0 square root of this. XL I am just writing omega square L square. I am writing XL as omega square L square. So look, this here, this is the voltage amplitude, this is the current. So this is actually having the dimension resistance, and you know this is actually, this is the effective resistance of the circuit. Okay, this is called effective resistance of the LR circuit, Effective resistance of LR circuit, which gives some or impedes the flow of current through it, through the circuit. Okay, so this is actually, this is having a dimension of resistance only, so it has got unit ohm only. Okay, V0 by dash, V0 by this. Okay, this quantity is denoted by Z and it is called impedance. So impedance means equivalent to resistance, but it is in the AC circuit. Okay, it is in the AC circuit. So this is called impedance, denoted by Z. Impedance, because it impedes the flow of current. So impedance of this LR circuit is Z is equal to square root of R square plus XL square, that is omega square into L square, where omega is the angular frequency of the signal, supply signal, L is the inductance, and R is the resistance of the resistor used in LR series circuit. Okay, so from here what we can see, look this figure. Okay, I'll just erase this a bit, then I'll write I0 is equal to V0 divided by Z, or V0 divided by square root of R square plus omega square L square. Okay, this is the amplitude of the current. See here from the phasor diagram, one can easily understand this. This is the current phasor, and this is the voltage phasor, and they have in between them there is an angle 90 degree. You can see that. So I have like this. This is VR also. This is VR also. This is VL. 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 Then where will be the resultant velocity? Sorry, resultant potential or resultant voltage. Resultant voltage will be like this, in this direction. If I say this resultant is V and it makes an angle phi with the VR, or the current direction, then what I can say? I can say easily from here that, in this case also voltage is ahead of the current. So I can say current is equal to I is equal to I0 sine omega t minus phi. So this is what we can see from the figure also. Okay. But what is this phi? How to determine this phi? Look, this is VL. I can just take it here. This is VL. This is VR, and this is V. Now it will be easier to find out what is phi. We can write, since this phi, this resultant voltage is making an angle phi with the VR, then we can write tan phi is equal to perpendicular by base. Perpendicular is VL by base is actually perpendicular by base. So base is actually VR. And what is the hypotenuse in this? This is V, that is the resultant one. Now VL, so what I'm trying to tell you here now, how to find out the phase angle. So tan phi is equal to VL by VR. So this can be again reduced. I0 XL by I0 R. So this I0 gets off, like they cancel each other. Then XL by XR. I'm sorry. This L by R. We can write directly. See, XL by R. XL by R means what? Omega L by R. Okay. So this is what we can see. So I'll just summarize here what we have got. we have got the voltage, sorry, current, amplitude of the current, that is V0 by Z. V0 is the amplitude of the voltage, supply voltage, and Z is the impedance in the circuit. What is that? Z is actually square root of R square plus omega square L square. Okay, so this is actually impedance, and we have got, if sub, see, if the current is, or if the resultant voltage is making an angle phi with the current, then tan phi is equal to VL by VR. That you can write. VL is I0 XL and VR is I0 R. I0 are the amplitude of the current. We can just strike them out. So XL by R. XL means omega L by R. Now we can find out one more relation. Like, what is cos phi? What is cos phi? Cos phi will be, see, this is actually now, okay, maybe we'll get one more figure. So I'll just write it once again. I0 is equal to V0 by square root of R square plus omega square L square. Okay, that is actually Z, V0 by Z. So that means it is V0 by Z. Okay, I0. Now we have this particular figure. So this is actually omega L I into omega L, I0 into omega L. This is I0 into R. Okay, so I can actually write this, like this thing in similar way. I can write this as simply omega or XL. I can write XL. This one is XL. This is XR. So what is this? This hypotenuse. Hypotenuse is nothing but Z. See, this is, so XL and XR square. So this is actually Z, right? So from this figure, what we can write is cos phi. Cos phi is equal to base by hypotenuse. Base is what? Base is VR. Hypotenuse or what? Hypotenuse is here. In this case, it is Z. Okay, so I'm sorry. This is okay. This is fine. So this we can write as, we can write simply as L and this as R. So that is also there. This is not VR. I think since we are writing in terms of Z and all, so this is actually L, this is R, and this is Z. So we will write cos pi means base R by Z. Z is hypotenuse. So this R by Z, R means what? R, and Z is, Okay, so we have got current through the circuit, and we have got the phase angle between the current and voltage through the coil. Okay, so this is about inductor coil, like series connection of L and R, and an AC signal. When an AC signal is sent through that, then we can write in summary, in case of this, like in summary, what we can write. In summary, we can write impedance in this circuit. Impedance we have already found out. What is impedance? Summary. Impedance is Z. This is for LS circuit. For LS circuit, it is square root of R square plus omega square L square. Okay, this could be written as well like this. Okay, so I think I am just mixing it up. It should be written XL, means we have to write XR. Okay, so this is about the impedance. And what is IRMS in this circuit? That will be given. See, VRMS will be given in the circuit. VRMS divided by Z actually. IRMS means IRMS means VRMS divided by Z. Okay, this is actually IRMS. Then we have learned phase angle phi. Phase angle phi, that means tan phi is equal to VL by VR tan phi lambda by perpendicular by base, or this is I into XL I into XL, and this is I into XR. And see, this I can get cancelled, so XL by XR. What is this XL? XL is actually omega into L divided by XR. XR is resistance of the pure resistor. So omega L by. So tan phi you have got. Again, one more formula you have got, that is cos phi. This is important in case of uh, finding out impedance and other things. Cos phi is equal to R by Z. Now we can similarly, okay, before we go to the shear circuit, let me discuss few numerical problems in this. So in this, there is a problem given here. When an inductor of inductance L and resistor of resistance R are they're connected in series across the supply voltage. This sinusoidal voltage then, because it has sinusoidal variation, frequency dependence or frequency variation. 50 hertz is the frequency of the supply voltage. Current is given. This current here actually is the RMS current. Okay, this is IRMS given. And the current current differs in phase from the applied voltage by pi by 3 radians. That means phi is given. We have to find out what is this R. Okay, so how to find out this R of the circuit? See what are the informations given. See if I require, I can find out XL, that is omega into L. Omega is given, see frequency is given, so I can write this as 2 pi f frequency into L. But L is not given. Okay, 10 pi. See, we can go for 10 pi only if we know XL by XR both, or the value of XL. XL means omega into L. But see here L is not given, so we cannot find out R from here because L is not known. So we have to go for cos phi. So cos phi gives R by Z. Okay, cos phi gives, like cos phi is R by Z, that we have already shown. So R is there here. Z is how much? So how to find out Z? (12 volt). Just a minute. There should be L given, I think. Let me see the parameters given. Okay, I see. See, one more thing is given, IRMS. So from there we have to find out Z. Okay, IRMS is 0.5. So this is actually VRMS by Z. So this is how we can get the thing. See, VRMS is given as 12 volt. 12 volt. We have to find out what is Z. So Z will be VRMS by RMS, IRMS. So 12 volt by 0.5 ampere. So this will give you ohm, right? How much ohm? 24. Okay, so 24 ohm. Now we know R. We have to find out R. We know this phi. Phi is given already. Okay, look from here. See, phi is given. So cos phi, that means cos pi by 3, cos 60 degree is equal to r by z. Z we know, we have to find out r. So r is z into cos of 60 degree. So r is equal to z, we have got this cos 60 degrees 1 by root 3, right? Sorry, cos 60 degrees half. Cos 60 degrees half. Then it is 12 ohm again. So it is 12 ohm. Okay. So this is how we have to solve this problem. So we need to know this formula then. This is important formula, cos pi is equal to r by z. Now we'll take up one more numerical problem related to this ALR circuit. See, a bulb of resistance 10 ohm, so resistance is given 10 ohm, and an inductor of inductance L. We don't know what is the inductance, so we have to find out. I think this is the question. In they are connected in series in AC signal. Okay, with AC signal battery. Say AC battery is this sending this 100 volt and 50. So VRMS is given 100. VRMS is given as 100, and omega, not omega, this is frequency F. F is given. F is given as 50 hertz here. 50 hertz. 50 hertz. So what we have to find out? We have to find out, see, if the phase angle between the voltage and the current, that means phi is also given. Phi is given as tan inverse of pi by 4. So tan by, see, pi by 4 okay, let us write for the time being. Phi is this. Phi is pi by 4. Phi is given as pi by 4. Okay. So we need to find out L. So we know tan phi is equal to omega into L by R. So R is given, omega we can find out. So L is actually R by omega into L. R by omega, sorry, R by omega into tan phi. That is equal to L. Tan phi, tan 45 degree is 1. And see, this is 10, and omega is 2 pi. F is here 50 hertz. Okay, and tan phi is 1 over 10 pi. See, this we know. See, we can write pi is equal to 20 by 7. 22 by 7. 7 goes up. So if we just do this division, see how much it is. 0.0 sorry, 0 point. So 1 will come, 0, then 2 will come, then you multiply 3, sorry, this is 40. So 1 0, write 1, it is around 8. So like this, so there will be, so this is actually, so 10 to the power 3, if we write in terms of 10 to the power 3, then 10 to the power minus 3, then how much milli Henry? So actually L is 0.0318 Henry nearly, or 318 into 10 to the power minus 4, right? That means 318, no, okay, 318. This is 10 to the power minus 4, right? So I have to make it 10 to the power minus 3 divided with 1. Okay, so 318 into 10 to the power minus 3. Okay, so I think this is 3 point. Okay, 3.18 milli Henry. 3.18 milli Henry. Okay, so that part you can just do it. So this is Henry. This much Henry is the inductance. Okay. Now we go for the second question. Okay, I think we can have another numerical problem on this. See, a coil of resistance 300 ohm and inductance 1.0 Henry is connected across an alternating voltage of frequency 2 pi hertz. Calculate the phase difference. We had solved problem when phase difference was given. Now you have to find out the phase difference between phase difference between the voltage and current. Okay, so this is what we have to do. So what are the things given? R is given 300 ohm, L is given 1 Henry, and frequency F is given 300 by 2 pi hertz. We have to calculate the phase difference. Okay, so phase difference, you know, in LR circuit, phi is equal to tan inverse of omega L by R. Okay, so L is given, omega we can find out, R is also there. So we can actually find out from here itself. So tan inverse omega is 2 pi into 300 by 2 pi, 2 pi f omega into L is 1 Henry and R is 300 again. So this actually will give you 1 only, 1. So tan inverse 1 means 10 pi by 4. So this will give you pi by 4. So this is actually the phase difference, okay, between the current and voltage. Okay, we'll just go for now. Series CR circuit is connected with a signal generator which is sending a signal, an alternating signal. V is equal to V0 sin omega t. In this case also we are not going to do analytically, we are just drawing the phasor diagram. If you remember, in case of pure capacitor circuit, when the same voltage was sent in a pure capacitor, when the R was not there in series with C, or in other words, in case of pure capacitor circuit, the current was actually ahead. Okay, current was leading. Okay, I think if you remember, the phasor diagram was something like this. This is the current phasor this is the current phasor and this is the voltage phasor. Okay, VC. Okay, voltage is actually this is actually some phi is equal to pi by 2. Okay, 90 degree. So this suppose this is omega t. Okay, so this is, so V is V0 sin omega t, phase omega t, initial phase is 0 actually, and current was found to be I is equal to I0 sin omega t plus pi by 2 plus pi by 2. This is what was obtained in case of pure capacitive circuit or pure capacitor circuit. And the phase difference, as you see, that is 90 degree. Now see, when I have, see this is yeah, so when I have both resistor and capacitor in series, then how does the phasor diagram look like? Okay, so phasor diagram will be looking like this. You can see I'm drawing the current and voltage across the resistor in the along the same direction, because there is no phase difference between the current and the voltage across the resistor. Okay, and see this is actually the VC. VC is in case of capacitor circuit, purely capacitor circuit, we have seen that the current is actually lead by current is leading by 90 degree. You can see this is pi by 2. Okay, this is pi by 2, this angle is pi by 2, this is current, this is voltage, so this is pi by 2. And see, I have to find out, see in this case also we'll be drawing the phasor for voltage across resistor, we'll be finding out the phasor of the voltage across capacitor. And this VC plus VR, vector addition, this will give you the supply voltage V, right? This is V. So now look, similar way, if we go, V is equal to V. See, I'll just go for amplitude part, okay? Amplitude part here, then V0 square is equal to V0 R square plus V0 C square. So V0 C square means, see, I0 R whole square plus I0 by, sorry, I0 into XC square. X means capacitive reactance that we have already seen, whole square. Now if we carry forward from here, so V0 square is equal to I0 square common R square plus X square, or V0 is equal to I0 into X square plus R square 4 to the power half, okay, or V0 by square root of X square plus R square. Okay, this is V0. V0 is the, sorry, V0. So V0, I0 will be like this. I0 is equal to V0 by this. So see, we can actually say this is the effective resistance in the circuit. Effective 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 resistance of the circuit. Okay, effective, here is the resistance, we can say this is actually called, say, this is actually called impedance. This is also called impedance. X square. X means what? X means 1 over omega square L square. Sorry, this is C square. Omega square C square. 1 over omega square C square. Okay, so this is about impedance. So once we get impedance, then can we find out IRMS? IRMS will be VRMS by Z. Okay. Now look here. If this is the VC and this is VR, then resultant will go somewhere like this. This is the resultant one. That is supply voltage as well. So resultant can be found out. See, from the parallelogram method, we have already written down the things. But what is the angle? If the angle that the resultant makes with the current direction or VR direction phi, then what will be the tan phi? See here also. So tan phi will be VC by VR. VC by VR. VC by VR. This can be written again I XL. If I say this is with amplitude, if we write, then this, and this also will be this. So XL by R, I'm sorry, this is not Excel. I'm just writing again and again. Excel, this is XC actually. VC means XC. So XC is what? 1 over omega C divided by R. So you get actually tan phi means 1 over omega C into R. This is tan phi. Okay. So what is tan phi then? Tan phi is XC by R. In the similar manner, what we have done in case of LR circuit. Okay. So here Z is actually Z is R square plus 1 by omega square C square. That is what you have to remember. So here also cos phi will be what? Cos phi will be R by Z. Cos phi also will be R by Z. So this is actually all about impedance. Let me write impedance. Impedance is this R square plus omega square, sorry, 1 over omega square C square. Okay, so these are few things which we need to learn about CS circuit, and say we'll just get numerical problems, at least one or two we'll do here, and then we'll stop our class today. We'll just take one numerical problem here, and then we'll stop the session. So question is, what is the value of current in AC in AC circuit containing R is equal to 10 ohm and C is equal to 50 ohm microcoulomb. I'm sorry, this should be farad. Okay, microfarad, not coulomb, microfarad. Microfarad in series across 20 volt AC mains, where 50 hertz is the frequency in India. Okay, so how to find out the current? See, R is given, C is given, then VRM is given, frequency given. So you have to find current. Current means IRMS. IRMS means VRMS by Z. So Z you have to find out. What is Z? Z is square root of R square plus 1 over omega square C square. So what is omega C? Let us write that. Omega into C. Omega C. Omega is 2 pi into 50. C is 50 microfarad. 50 microfarad means 10 to the minus 6. So 2 pi into 25 into 10 to the power minus 5. Okay. I think this requires Okay, so r square, r is 100 anyway. This is r square means 100 plus this square we have to make 1 over this square. So 2 pi 25 into 10 to the minus 5. Okay, so if you just do this calculation, then you will get nearly, you need to just do this calculation or simplification a bit. This is actually Z. Now we have to find out IRMS. So VRMS by Z. So VRMS is what? 220, right? 220. And Z we have found out what? 64.4. This will give you the current around. So this is the current. Okay. So we'll stop it here for today. In the next class, we'll learn LCR series circuit. Okay. Series circuit across an AC mains. Okay. So when an LCR circuit, that means, see if I write LCR, C and R in a series with a battery producing alternate signal or signal generator. So this is L, C and R. So this circuit we will analyze tomorrow or in the next class. Okay. So thank you for your patience. Bye for today.